I just start a brand new installation of Anaconda, and I'm going to walk you through the process of how to do stock like algo trade in Anaconda Jupyter Notebook. So first of all, we have to install Anaconda. So let's go to your browser. Whoops. Anaconda installation. And then you go here. It's Anaconda website. Okay, and this one, Anaconda installer for Windows. Okay, so go to this website, Anaconda download, and then simply click Windows, Mac, or whatever. But in our case, I'm going to download Windows, and I'm going to download the 3.6 version. This one. Yep. So it is this one, 3.5.1. So let me just save it. Yep. I have installed that before. So I'm going to use this one. Let me just remove the one that I just did. Okay. So I'm going back. Let's say if I have just downloaded that to my D drive. Let me double click it and then start the installation. Oh. And let's click next. And then you agree. It's just me. It's okay. For a destination folder, I just pick D drive, save to the, just don't want the user. Let's see if I can just save it to Anaconda free. Click next. Okay, so just take that, leave it, and install. Okay, so it's completed, and then I click next, untick these two, and go on with finish. So, if you go to the start, and then you will see Anaconda 3. So when you click Jupyter Notebook, you will get to a place. Okay, let me click Jupyter Notebook. So you have to wait quite a long time, yeah. And it's going to launch the browser. As you can see, it's going to save your Jupyter Notebook in your root folder, which is here. Let me show you. Should be this one. C drive, users, user, and then here. Let me zoom that in. So it's going to save in your root folder. But that's not what you want because I don't want to have Jupyter Notebook files saving here, right? So let me just log out this one. And I have to log out of the Jupyter Notebook, this one, by pressing the Ctrl+C, Ctrl+C twice. Okay, so I just figured out how to create a new environment in Anaconda. First of all, go to Window, and then you go to Anaconda, which is this one, Anaconda, and then you go to Navigator. See if I can show you. Navigator, Anaconda Navigator. So it's gonna load quite a while. When you get to Anaconda prompt, make sure you check the applications on this one. But you haven't created this environment, right? So we have to click the environments. Let's pretend that we are not going to use this one. So we are going to create another one. Okay, this one, create. Just click it, and then you will have a prompt to create new environment. So I just called it my tray. So it's totally up to you what name you want to give it. So just call it my tray, and I only want Python 3.6. If you want 2.7 or 3.5, feel free to take the other one, but I want 3.6. So I click create, then I am going to generate another environment. It's going to load quite a while. Just go back. So we're done. And you see all the packages you have in this new my tray environment. Go back to home. Make sure you click, let's say if you are on root or something like that, make sure you tick my tray. Okay, the environment that you just create. And then I need to install Jupyter Notebook. So just install that. So make sure we can use the Jupyter Notebook afterwards. I tried this morning and I was on the route. I didn't install the Jupyter Notebook. That's why I can't get the Jupyter Notebook command worked. So make sure you install the Jupyter Notebook, this one. But don't launch it here because you will get to the root folder that I showed you before. And now I'm going to install new packages. So go back to environment, so make sure you are in my tray. Let's say we don't have pandas data reader, right? We don't find pandas data reader and pandas. Just click here and click all. And then you type pandas. When you click pandas, you see pandas and pandas data reader. We need these two. So we click these two and then we click apply. Go to the bottom right corner. Click apply, it's going to install. So these will be installed, okay, to your new environment. So I'll click apply. So it's going to install to the new environment. Okay, it might take quite a while. Okay, so I think we still need XLRD. So we need to export to Excel. So this one, let's say we need XLRD. So it's not inside our my tray environment. So just take it and then apply. So it's going to install to our environment. So just apply, should be fine. It's going to apply the installation here. So it should be, yep. So it's installed. So before we go, let's check what packages we have in the environment my tray. Click here and then you click install. Oh god. Just these are all the packages we install. We should have pandas. Yep, pandas data reader and XLRD. This one, XLRD. So we are good to go. Let's close the Anaconda. Close it and then quit Anaconda Navigator. So before we do anything, let's create a folder. Let's say if we create another one, I'll just call my tray scripts. So I'll just call it my tray scripts. Then go to window here, Anaconda, and then you click Anaconda prompt. We're going to use the Jupyter Notebook now. First of all, we need to navigate to the folder that we just created. So it's my tray script. And then we need to activate the environment that we just create. I think it's my tray. Should be this one. Yeah, should be. Yep. And you can see the environment name, my tray, inside the bracket. And this is the folder that we are going to save our Jupyter Notebook file. So Jupyter Notebook, and then press enter. Okay, so we are going to be getting here. So let's say if we create a new Python file, Python 3, let's give it a name. Just click this untitled or whatever name, and then just call it test tray, and then click rename. Then we have a new tray file. Okay, so let's check if we got this file. So just go back to my tray scripts. And then we see the test tray Jupyter Notebook file. Let's start typing some code. Let's say we can run pandas and pandas data reader package that we just installed to our environment, my tray. So import pandas as PD and then shift enter. If you see no error message, then it's good to go. And then we can try pandas data reader as PDR. It doesn't matter if you name it AFD, whatever, but it's just convention that we just do. PDR stands for data reader. Okay, and then if you want to run the code, shift enter. Let's say if you want to run all the code, it's inside cell and run all the code. You just run SciPy, which I don't have, right? As SP, then shift enter, then I should have an error message because we don't have this package. We changed this already. So we import pandas as PD. We don't want to scroll all the way back up. Then we just go to cell and then run all cell. Then it runs this cell, and so on. In the next video, we are going to start off our backtest on Anaconda. Okay, so let's get back to our backtest model. This is my first time creating backtest in Anaconda. Let's go to Windows and then scroll through Anaconda free, and then you navigate to Anaconda prompt. So we navigate to our Jupyter notebook folder, which is D drive. We are going to navigate to is my trade scripts. So let's go back. It's going to be my trade script. And then we activate the environment, which is my tray. Under the virtual environment, my tray, just type Jupyter notebook. Let me scroll that and press enter. Our notebook start here. Let me make it full screen. So we can start test tray Python. Just double click this and get in. Let me delete it. Delete. Yep. Delete cells. Delete cells. So we start everything brand new. Very first step is to get the stock data from Yahoo. So in this case, I'm going to do AAPL, which is import pandas data reader as PDR. And we are going to save it to AAPL. You can give a name for whatever. So usually you give it df data frame. So df equals pdr dot, and then the action is get data Yahoo, and I'm going to get AAPL. We are going to get Apple stock data. And this time, because we are in a Jupyter notebook, we don't need to do print. We can just press shift enter. You know what? We have thousands of rows. Hey, come on. Just print df. Okay, anyway, we need data frame. So you see the stock for Apple is from here. So we just grab the stock. If you want to look up for the first 5 rows, and then, so I just need df.add and df.tail. Just look up for the first 5 rows and the latest 5 rows. So I press shift enter. Okay, shift enter. Okay, so we have this, the first 5. Oh, I mean, this is the latest 5. So if I do this, shift enter, and I should get the very beginning. Just as I said before, so we have to filter out the non-trade days. So we need to filter out the days that volume is not more than 0. I just call it df1. It equals to df square bracket and then df again, because we are going to include the criteria. And we need the criteria is our column, the volume, and then it has to be more than 0. So let's print df1 dot tail to see. Shift enter. Okay. Grab the data. So we are going to save the data to an Excel. Okay. So shift enter. So here from the second cell, we are going to save it to Excel. So let's call df1.tail and check. Shift enter. So we see this. We need the df1 to Excel. Before that, we define the data source. Data source equals, just give it a location and just save it to tutorial. Okay. Tutorial, just call it aapl.xlsx. Okay, so it equals to data source, and then shift enter. Hold on, how come? Oh, you know what? We don't have the module openpyxl. Let me just save it. Save it first. File, save and checkpoint, and then let me close it. Go to file, close and halt, and then log out everything. Control C, exit, and then I go back to Anaconda Navigator. So just go to Anaconda Navigator here. Click it, and let me install the package OpenPyXL. So you usually encounter this when you don't have the package. It's very common. Just a good way to learn how to create the program with your, okay. So first of all, make sure your applications is on your environment. Okay, so it's on my tray. Go to environments. Let me just type OpenPyXL. We don't have that. That's why we go here. We go here and click all. Okay, then we get this. Simply take it and then go down to the bottom right of Anaconda and just apply getting the package. Oh, how come it's that slow? Okay, so we get it. Then we just apply and it's going to install the package on the my tray environment. So let's get back to here. Let's go to install and check whether we have the OpenPyXL. Here, this is the OpenPyXL we just installed. Okay, then let's go back. Let's close the Anaconda navigator. Let's go back to Jupyter Notebook. So this time I'm gonna be very quick. This time I just navigate and then go to my tray scripts and then activate my tray and then Jupyter Notebook. Enter. That's one of the reasons why I don't really like Anaconda. It takes way longer to load than the Sublime text. Oh yeah, it's loading. Okay, anyway, so we get back to our test tray. So this time, we got the package, OpenPyXL, and then I press Shift Enter again. df1 is not defined. Oh, you know what? You got this because you need to run everything. So that's why we go back to Cell and then run all. So this time should work. Oh, how come? Oh, I see. Okay, before we do that, you know what? I need to create another location first. So I just call this data file. Okay, so I just save it here and then I just name it AAPL dot. Oh, I just save it as CSV because I don't have Excel here. Okay, I just forgot. Okay, so it's fine. Perfectly fine. Just name it as data file. And I'm going to save it as, oh, I try Excel first. Even though if I don't have Excel, Control Shift. Yeah, good. Oh, even if I don't have Excel, I can save as Excel. Very good. Let's get back to, let's see what we download. It's in the data file, D drive data file. And then we got this. I can't open this because I don't have Excel here. But I can try reading this one. So next one, name it as data file, okay? Just to distinguish between data source and data file. And I just copy that. So it's D drive data file AAPL.XLSX. Let's say, oh, I have an import pandas. So I need to import pandas as PD and NumPy also. Okay, NumPy as NP. I call it df. df equals pd dot read Excel from what? From data file. And let me print the first 5 lines by pressing Shift Enter. I'm just reading the data file, not the data source, even though they are the same because I'm showing you that I can read the Excel. So let's say if I want to read the tail. So I can read the tail. Let's take a break first. Okay, so I'm back. Last time we have just tested reading the Excel file. I'm going to call all the file again. Okay, so just run all. Make sure they all run. Okay, it takes time. Don't need to run it one by one. I will just try reading this one, Shift Enter. Okay, good. So I can go ahead. The first thing first is we are going to define our strategy. So we are going to use the class keyword and define our strategy. Class, we need to initiate that. So we need to give it a name, right? Tname equals tname. And remember that outside the class, I just called it global variables. Okay, so and I define the name here so that we can change outside the class. And it adds more flexibility to our strategy. But in our case, it is a very simple one. So it doesn't matter if we include the attribute inside the class or outside the class. So I just call it MAV because we are using the moving average crossover. Stands for MAV. And we are going to define the long run. So the use of self, just like what I said in the previous video, it is the abbreviation to point to the strategy. It is an instance in the class strategy. It's just like when you raise your hand. Raise your hand is just one of the many instances in your life. You raise your hand, you put down your hand. These are the two instances in your life. So that's my analogy. And we create the short run, which is the short term day. We define the long run and short run. So I just call long run equals 20 days. Short run equals 5 days. And you can always change that to whatever days you want. And we need to define the condition when we need to calculate the moving average. Just means the DF index. The index is just like this one, 1972, 1973. It is the data frame index on the table here. So that it just gives a name to the row. So the index has to be more than the self.long_win. Okay, hold on. Let me just change this one. DF 18, the 18th row to 30. Shift enter. Let's say if I want to calculate a 20-day average, I have to get at least 20 days, right? That's why I have to start from this row, the 20th row. If I calculate the moving average of the adjusted close, I can't do it on the 18th day because I only have 19 days. The first day is 0. I can show you like because the first day is 0, so that we need to start from the 19th day. Okay, actually I can just add it to 20. It just doesn't matter. Actually, the first day of trade doesn't do much. So this is the condition that we are going to calculate the moving average. Let me talk about the strategy a little bit. Our strategy is if the short-term moving average of the adjusted close is higher than the long-term moving average of the adjusted close, then we are going to generate a buy signal, which is 1. That's the one that will be defined in the signal class. And if the short-term moving average is lower than the long-term moving average, then we are going to sell. The signal will be -1, but we can buy or sell before the day ends, right? That's why we are going to... So let's say if this one is 20th day, and then I'm going to buy on the day after, which is the 21st one. Let's say if I have a sell signal on the 22nd day, then I'm going to sell on the 23rd day. So that's why we need to define the trade price to be the data frame, which is DF, the open price. So we need the single quote and open. The open is here. This is the open, the column head. And we are going to define the close price. Self.close equals to DF. Instead of using the close price to calculate the moving average, we are going to use the adjusted close because it just takes into account the stock splits, stock dividends, something like that. So this one is ADJ close. Okay, so we are going to calculate the moving average to add in formula or something like that, right? So we are going to point the SMAV, the method, back to the class object. Then we need that. Okay, just comment that out. And our self.SMAV, this self.SMAV is pointing to the method SMAV instead of to the strategy. And our short-term moving average equals what? Okay, so we have NumPy, so we can use the NumPy dot where. It just means when we start the strategy class, strategy, which is this one, strategy. And just remember when you quote it inside the class, you have to use the bracket. Strategy dot condition, which is this one. So I'm just referring to this one, self.condition. The condition is what? It's when the index is more than the day we start calculating the long-term moving average, which is in our case, the 20th day. So when we start calculating the average, we are going to use the strategy.close because we are calculating based on the close price. The strategy close is going to take rolling dot mean. The rolling means how many days we are going to roll. And in this case, we are going to roll the short win, right? The 5 days. So we need the window equals strategy dot short win. The short win is coming from here. Short run, sorry. I'm sorry, I'm just too bad today. So I just need to change this all to win. This just to align. So short win. Not run, sorry. So it's short win, and then we take the min. So we're calculating moving average. Otherwise, we have 0. When the condition, which is this one, we need to calculate the moving average. We start calculating the mean of the adjusted close price, rolling for the short win, which is 5 days in this case. So we need to return self.smav. In the global variables, let me print it. So we just define df, we just add one more column, smav equals strategy. But I don't want to type strategy again and again, so I just define s equals strategy class. So it's s.smav. It is a method. That's why I need the bracket here. And let me press Shift Enter to see what we get. Oops, how come it's wrong? It's wrong since. Oh, sorry. I forgot the space. So this time should work. Why programmer takes so long time to develop the strategy. Okay, Shift Enter. So this time should work. I forgot. Okay, so let's print df.tail. Shift Enter. So we have the moving average here. Short-term moving average. Basically, you can copy this one for the long-term moving average. LMAV, just change to LMAV. The strategy condition doesn't change, still starts at the long-term one. But the rolling window has to change. The rolling window is not rolling for 5 days, not the short win. It's the long win. And we return the LMAV. We are still inside this cell. And we have variables. Let me add one more column called LMAV equals strategy.lmav. It's a method. So I need a bracket. Shift Enter. So this time, oh, you know what? Typo again. This one, LMAV. Oh, too bad. Shift Enter. Just have a bad day. We have this LMAV. So when SMAV is more than LMAV, we have a signal 1. And then for SMAV lower than LMAV, we have a signal -1. Let's take a break first. Alright, so let's get back to our backtest model. So let's define the trend day inside the strategy class. And the trend day is equal to numpy.where. So if the short-term moving average is more than the long-term moving average, then we return 1. Otherwise, we have the numpy.where again. Otherwise, if the SMAV is less than the LMAV, then we return -1. 1 is up and -1 is going down. Otherwise, it's 0. So let me change the SMAV to strategy class.SMAV. Oops. SMAV, and SMAV is a method. So we need a bracket, and we do the same to the LMAV. Okay, so we do the same for the strategy class.SMAV bracket and a strategy class for the LMAV, so LAMV. So just be careful with your spelling. Okay, and we return self dot trend day. We're going to add one more column that's called trend day to see what we get. Actually, in real case, you don't really need to show. Okay, so I'm just showing you here. So it's equal to the strategy class as trend day function. So it's a bracket because it's a function. So let's run again. Okay, shift enter. So this time we get this. Actually, let me print this one. I just press 80 to 30. Shift enter. So when SMAV is lower than LMAV, we define this as a down day. Okay, so let's look up for a up day. Okay, so let's press F35 to 55. Shift enter. We have SMAV more than the long-term moving average, then we have 1. Okay, so next we need to compare today's trend day and last day's trend day. When it returns 0, it's a change of trend. So we need to define the previous trend day. So usually I'll do trend day because we just add the prefix to trend day, that is the one that we already create. So that's my convention. Easy to manipulate your string, and we use the previous trend day equals. We use the numpy dot where again. When we start calculating the moving average, we are going to shift 1 day back up to get the previous end day. Otherwise, it returns 0. So let's change that by strategy class dot condition, which is this one. Strategy, self-pointing to strategy condition, which is when we start calculating from the 20th day, the long-term moving average, then we are going to use the numpy dot roll by 1 day, and we are rolling which column? We are rolling the strategy dot trend day. It is a method, so we use the bracket. Okay, otherwise it returns 0. So let's return self dot previous trend day. So let's add one more. The previous trend day equals strategy dot previous trend day, and then shift enter. So let's just pick another day, 85 to 125. Shift enter. Okay, so we have this. May 7th, 2010 is a down day, and the day after, when we move to the next trade day, which is May 10th, then we look back, we have this -1. When we look back, we have this 1. So that's why when -1 plus 1, which is also -1 plus previous trend, which is 1, then we get 0. Then we know on May 7th, 2010, we will have 0. We have change of trend. So whenever this row, -1 plus 1 equals 0, or +1 plus -1, let me see if we have, yeah, this one, June 1st, +1 plus the previous day's -1, we get 0. So we know this is a change of trend. That's why we need to create a difference between trend day, and this is just the diff trend day equals strategy class dot trend day, which is today's day. It is a method, so we need a bracket plus strategy dot previous trend day. We just return self dot diff trend day. Print that out. We just add one more column. Previous difference trend day equals strategy dot diff trend day is a method. So shift enter. So we trend day. So it is down today on May 7th and it was up on May 6th. So we get 0, the difference. And we will generate a signal 1. You may ask why we calculate it and we're not directly going to signal class. Because in complex systems, we just want to separate these things. The strategy, these are the attributes from the strategy class. We just want to separate these from the signal class because you may mix different strategies into one signal. That's my setup. In this case, it's a little bit straightforward. Okay, so let's take a break. And now we are going to the signal class. So we are going to generate the trade signal based on the strategy we define. So we are going to create a class called signal. And we need to initiate it. The first method we are going to create is the trade signal. So self.trade signal equals, we know that when the difference trend day equals 0, this one, then we know there's the change of trend. So we generate signal for May 7th. We just use numpy.where. We use this again, where the difference equals 0. Then we generate the signal to be equal to the trend day, right? Because the trend day tells us whether it's 1, is up, or it is -1, going down. So we just return a trend day, otherwise return 0. So let's change that. Because the difference is from the strategy class. So we use the strategy bracket dot the difference trend day. The difference trend day is coming from here. Difference trend day, which is this one. It is a method. So we need a bracket here. So when it equals to 0, we know that we need to return the strategy dot trend day. Trend day is also a method. So we need a bracket. Let's go back and return self dot trade signal. We want to use, I just give it a name, TS equals signal class, so that I don't need to type signal bracket again and again. Okay, so let's create a new column to see if we get it right. So trade signal equals TS, which is the abbreviation of signal class, dot trade signal method. I just print the 85 to 125. Let's print that out. Shift enter. So we have the difference of trend is 0. So it's a change, right? Because it's going down on May 7 and it was going up the day before. We just return the trend day of current day, which is -1. Okay, otherwise it's 0. And also this day, June 15th, going up today and it was going down yesterday. So it's a change and we return the signal of current day, which is 1. We generate the signal, but we cannot trade on the current day, right? Because we generate the signal based on the adjusted close. That means we only know whether we are going to buy or sell at the end of the day. So we cannot trade at the current day, right? So we can only trade based on our signal on the day after. Trade at the open price or whatever price the day after. So we are going to define the order when the time when we are going to place our order. So we just know that self order equals to, and we use the numpy.where function again. When we start our calculation of moving average, the condition, then we are going to return the previous day's trade signal. We can use the numpy.row and we are going to roll one day, rolling the previous day's trade signal. If the previous trade day was a buy signal, then we just return a buy signal and vice versa. Otherwise, we return 0. So we go back to the formula. When the condition of the strategy class holds, then we are going to roll back to previous day's trade signal to be our order. So we are going to return the signal class dot trade signal, which is here, and we roll back by 1 day, which is the previous day. Otherwise, we return 0. Okay, then we return self.order, and let's print out one more column to see if we are right. Order equals signal class dot order, and it is a method, so we need a bracket. Shift enter. Just roll. Oh, found method. You know what? I must have something wrong here because I forgot the bracket again. The trade signal. Because a trade signal is a method. Okay, so let's do shift enter again. Okay, so when the previous day, which is May 7th, is a sell signal, which is -1, then today we are going to sell. It's based on the previous day's trade signal. Also the same, let's pick the day. So when the previous day was a buy signal, a +1, then we are going to buy, place the order today. So that just finish up the signal class. Okay, so here we have class portfolio. And again, we need to initiate it. And this time we have several attributes to include. And the first thing we need to define is the lot size long. It determines the number of lots that we are going to buy. So it's a long order, right? Long. In this case, I just use 1. Okay, it doesn't matter. And lot size, same case for short. I just make it 1. It just means you're going to buy 1 lot, right? Per long order. And 1 lot per short order. You can always adjust this one. So you can change to 100 or 10, something like that. For simplicity, I just make it 1. And we need to define the contract size. That means the number of shares or number of the whatever assets you're going to buy per lot. I think I'll just make it 1. It doesn't matter for this case because we are doing Google. We're not doing another stock. So I'll just make it 1. But again, you can always change that. Let's say during the past 100 years, it may like period 1, then it has 100 shares. Otherwise, it's like 50, whatever. Feel free to change that. But in this case, I'm going to just make it 1. We need to define the initial cash. That's the amount we invest, we put upfront. So in this case, just put 1 million. And so the other one is self.long amount. It's going to be equal to -1 times this one. So everything is in between numpy.where. When the order equals 1, it is a buy order, right? So we are going to multiply the lot size long, the number of lot we are going to purchase times the contract size, the shares per lot times the trade price, which is the open price. Otherwise, it's 0. So the signal is under this order is under the signal class. So we put signal.order equals 1. So it is a purchase. Then we are going to let me try self because self is pointing to portfolio. So let me try this. And again, you know what? I forget the order. The order is a method. So when you check signal class, order is a method. So I have to include a bracket. Otherwise, you will have problem. So gotta be really careful. The self.lot size here times self.contract size times strategy class dot trade price. Otherwise, it will be equal to 0. So let me try printing out, adding a column called long amount equal to, it's abbreviated SP, portfolio dot long amount. This time we are not using the method, so we don't need to include the amount. Oh, you know what? I forgot the print. Because I can print this one. So as you see, I use the dot look. So the look is wrapping around the row, which is from the 100th to the 120th. And I'm just printing these columns instead of printing open, high, low, close, because we don't need the open, high, low, close. So we press Shift, Enter. So we get this. That means we are okay now. We can just wipe this out. And for the short amount, which is the amount that we are going to receive, just paste it and change. So I'm just getting lazy. So the short amount, it doesn't equal to a negative number because when you sell the stock, you're going to get money, right? So it's a positive one. So instead of wiping this out, I'll just keep this because it just reminds me direction of the cash flow. So when the order equals -1, wrap around with a bracket, then I'm going to sell the lot size short. The contract size stays the same and the sale price stays the same. Otherwise, it's 0. Let me print the short amount equals p dot portfolio dot short amount, and I'm going to include that here. So short amount. So let me press Shift Enter. So when you scroll inside the short amount, the trade signal is -1, we can trade, right? But we place the order here, -1, and I should buy one lot of share at 35.46. And I just assume that I'm just buying one share because our contract size is 1. So the next amount that I'm going to calculate is the daily change of cash. Find cash delta equals, so the self.cash delta equals this one. Oh, excuse me. Just paste this one and then return self.cash delta. Hopefully it works. So this time the cash delta, it has to be a bracket because it's a method. Okay, so Shift Enter. Yep, this time it works. So you see cash delta, so you just add them both, add a negative number. Okay, so in this one, how come this one is negative? Yeah, I'm buying. And this one is positive because we are selling cash. Doing something wrong. So let's do again. So we define the end balance. So it's just equal to, okay, self.end balance equals to the portfolio's startup amount, initial cash, initial cash, $100,000, and it adds the portfolio class dot cash delta dot consum, and then we return the self dot end balance. We're going to add a column, end balance equals portfolio dot end balance method. Remember to include that in our print, in our dot look location. So Shift Enter, and it's going to minus this one, and you get lower 96. So when you add that back, then you have 35. Then we're going to calculate the position, the ending position each day. So the ending position of the portfolio is just the signal class order, the consum, the accumulation of the order. Okay, so return self.end. Again, we're going to print that out. So it's ending position equals to portfolio dot end post in the method Shift and oh, sorry. You know what? I forgot to include that here. So just end position. Okay, just click somewhere and then Shift Enter. So we have the position. So for a day, we place the order 1, then we are going to pay this amount, and then we get one more stock. And up until here, we are going to place the order of selling stock at this amount to get this amount. 1 minus 1 equals 0. Okay, so it's the running total. That's it for the portfolio class. In the next video, I'm going to calculate the profit and loss and graph it so that we know whether our strategy makes profit or not. I just forgot to complete my Jupyter notebook. So let's get back to our backtest model. Since I just created the plot here, so I have to go back to shoot this part. So I'm just showing how to calculate the profit. Let's here. Comment out everything. We are going to create a column in our data frame in our table called PnL. Just call it profit and loss. Actually, it should be named portfolio value because it has two components. It has the cash balance and it has the unrealized portion of our portfolio. So the cash portion is easy. It's just the ending balance running total that we just did in our portfolio class. And the unrealized portion is just the ending position multiplying the trade price. Let's say if we are going to calculate our profit on October 12th, even though if we don't have any signal to buy or sell, we just assume that we are going to buy or sell at the trade price, which is the open price of the day. That's why we are going to multiply our ending position by the trade price. And then we need to multiply the contract size. In our case, our contract size is 1 and our lot size is also 1. So 1 times 1 is 1. But in many other cases, the contract size may be 100 shares per lot or like 500 shares per lot. We need to multiply the ending position to get the exact number of shares that we hold or we need to sell. In case it is a positive one, it is a long position. So we assume that we are going to buy at this price. So in case if the ending position is -1, then we are going to sell at the open price. And since if it is a -1 times a positive number, it's going to be subtracted from the total portfolio value. And we go back to our formula. It's the portfolio class dot end balance because we did that about multiplying the strategy class dot trade price. And then we need to multiply the portfolio class contract size. I'm going to graph from the data frame and we are specifying the column and rows by the dot load function. So it's just like df dot load. And then a square bracket is a row, the range of row and the specific columns. Since we have like almost 2,000 rows, so I'm just slicing only the 1956 and the 1976 column. So it's just the latest 20 days. We're going to use the square bracket to specify the columns that we are going to create. So let's say if I don't want trend day, I'll just remove that. Okay, so before we press Shift Enter, just make sure you're just restarting the notebook, go to Cell, and then run all. Okay, just run all to make sure the code about is properly run. Oops, how come this one we don't get it? Oh, you know what? The position is a method. And I just forgot to put it back. Contract size and the price are just instant, so it's okay. Oh, I know why. So then we go back and press Shift Enter. So this time is good. Okay, so that's the part we are going to. Okay, so we just finished off with the portfolio. In my Jupyter notebook, I just don't have the module Matplotlib. Let me install that. We go to Windows, go to Anaconda. And then I go to Anaconda Navigator. Okay, so first of all, we go to the application on and click the environment. If you're in root, then it's perfectly okay, but I think it has Matplotlib installed already. But for my newly installed environment, my tray, I don't have that. After I click in my tray, I go to environments. And then make sure I'm in my tray. And let me just search Matplotlib under install. Matplotlib. So make sure I don't have Matplotlib. Then I go to all. and then I click matplotlib, just type it, and then it's just click this one like this. So I just take the matplotlib, and then I go to the bottom right and apply. Oh yeah, so we got all these items. Then we are going to apply, and then it's going to install the package to our environment. Keeps installing. Okay, so our packages are installed. So let's just go back to check if our environment, my tray has matplotlib installed. So I just type mat. Okay, so I see matplotlib already. Okay, so then it's done. Shouldn't take long. Yep, very good. Then we get back to script. Our Jupyter notebook should be. Okay, so before that, since I have multiple cells, these are called cells. So I'm going to click cell and then run all. Okay, just run all cell because I have to run going from top to bottom. Then I'm going to just reset the index, so it doesn't matter because here, okay, so I just import matplotlib.iplot.splt, and then just run a line matplotlib inline just to show the graph inside Jupyter Notebook. And I just create new data frame called df1 equals df.setIndex. Whoops, because I want my, okay, yeah, should be this one. So I set it to date because our data frame, which is this one, df, I just extract several columns here, and I want the column date to be the x-axis. So let me see. So let me call print PnL equals the table, and then the column name, right? The column name, and then I plot just dot plot. So I change the table to what? To df1. And the column name, I just want to show the profit and loss. That's the one I just created before. So it's PnL. Okay, then I want to show plot dot show print. We're going to plot the profit and loss of our backtest with date to be the x-axis. Press Shift Enter. You know what? Typo again. Index. Some of the characters. So okay. So we do that again. Shift Enter. Wow. How come? Oh, plot dot show. Oh, you know what? Even though it doesn't define, it's still plotted. But it doesn't matter because it's not plot.show, it is PLT, because I forgot. The dot plot is a method inside matplotlib, and the plot is the abbreviation of matplotlib. We use the matplotlib's function, .show function, to print the print PnL variable, which is the column PnL of df1 table, applying the function .plot. Okay, so let me just press Shift Enter. That's the one. So we start off with, let's check our portfolio. So we start off with $100,000. You see this initial cash, the ending balance. Oh, you know what? I forgot to multiply the contract size, but it doesn't matter because it's one. Like that's, so we're still making money. $100. So that's how we did for Apple if we follow the moving average crossover strategy. Okay, so that's basically it. Hopefully it helps.